Okay, reaction of free radicals. Free radicals are highly reactive because of unfair electron present in the carbon. Some of the most observed reactions are free radicals are chain propagation reaction, abstraction of hydrogen, this methyl free radical, and this attain one electron, single electron movement and forms this methane and this methyl free radical. Abstraction of atoms or groups other than hydrogen. And this the methyl free radical is the chlorine and single electron movement and forms methyl chloride and chloride free radical. Addition to double bond, this the methyl free radical, and this methyl free radical attacks on this carbon and single electron movement from this double bond of carbon and forms this free radical. This is the 1 degree, so it is the less stable, and rearrangement takes place at 2 degree more stable. Dimerization reaction, simple free radicals like alkyl free radicals undergo dimerization reaction to keep the stable product. It's the dimer. Disintegration reaction, some free radicals emit neutral molecules to keep a new free radicals lower in masses. The reaction is called disintegration. C, and this free radical and disintegrate and produce this phenyl free radical and carbon dioxide. Substitution reaction of free radicals, initial step, a halogen and an alkane will not react without UV light. The UV light is required to form a halogen radical. In this example, the UV light gives the energy to the covalent bond in chlorine so that it undergoes homolytic fission, producing two chloride free radicals. Homolytic fission of chlorine UV light to form free radicals initiation reaction. This chlorine and UV light chloride free radical. Propagation. As radicals contain an unpair electron, unless a radical is reacting with another radical, the products produced must also contain an unpair electron. New radicals are therefore produced when a chlorine radical reacts with an alkene. This produces new radical is formed, and this methyl free radical and this chloride free radical. Termination, and the two unpaired electrons combine to form a bond between the two species. Products are no longer the radicals. Chloromethane, further substitution with chloride free radical, dichloromethane, and further substitution with chloride free radical, trichloromethane, further substitution with chloride free radical, and tetrachloromethane. This is the UV light and produces bromide free radical. I like bromination when the N-bromo succinimide in the UV light groups adjacent to the alkenes will be covered into alkyl bromides. Mechanism at an aromatic substrate when add in the reaction from Rx to Ri. Aromatic, the simple abstraction mechanism may be operating, especially in the gas phase reaction. Aromatic group and aromatic group forms coupling in the gas phase and coupling in the solution phase as mechanism similar to the electrophilic and nucleophilic aromatic substitution. Mechanism at the aromatic substrate, simple coupling, disproportionation. In case of disproportionation, this forms the one abstraction of hydrogen from the another. If the species R is present, initial step 1, The initiation step involves the homolytic cleavage of chlorine bond to form two chloride atoms. Step 2, and methyl free radical is form methyl chloride. Step 3, in the termination step, the radicals combine in all possible combinations, chlorine gas, this methyl chloride, and this ethane, methyl chloride, ethyl bromide. Fragmentation. Many free radicals are generated by a fragmentation process in which some initially form. Radical loses a small suitable molecule. See in this example, this free radical and produces this nitrogen. And from the azide, also from this example, produces two free radicals, phenyl free radicals. Decarboxylative halogenation of carboxylic acid forms the basis of the Huss-Dicker reaction. In this reaction, the silver salt of the carboxylic acid treated with halogen to produce haloalkane, accompanied by the loss of the molecule of carbon dioxide. See in this example, first of all, this acetate, silver acetate reacts with bromine, and single electron movement and produces two free radical. Again, carbon dioxide removed and ethyl free radical, and these two free radical combines and forms bromoethane. Addition reaction of free radicals. Typically, a free radical initiator adds to a molecule of alkane to start a chain reaction. I hit it, and this produces phenyl free radical. Again, combination. General mechanism of free radical polymerization. Initiation, free radical generated. This is the propagation. Oxidation of other free radical. Oxidation of free radical, cleavage of oxygen-oxygen bond of the hydroperoxide, and degradation of the resulting alkyl radicals produce aldehydes and ketones, and also further oxidation into carboxylic acid. See in this example, this free radical single electron movement and remove this hydrogen free radical and another this free radical. So, and again combines with oxygen, and this free radical combines with this hydride free radical and forms 2-butyl hydroperoxide. In the 2-butyl hydroperoxide, again, this hydroxide free radical is removed and forms this free radical. Again, this free radical moves here, and this covalent bond of single electron moves toward this, and this part is removed. So produces this aldehyde, ethanol, and again further oxidation of this ethanol produces carboxylic acid. Reduction reaction of free radicals, reduction carbonyl groups begins by the transfer of an electron from the metal to carbonyl group. Okay, this propanone reduced by sodium, a reduction of free radicals. In this reaction, the carbonyl group begins by the transfer of single electron metal, that is the sodium 2 carbonyl group. This is another one example. This is the mechanism, and sodium transfer this electron, and this sodium and this hydride abstracts from this hydroxide free radical. Again, this sodium transfer electron and 2 electron and abstract this hydrogen and this oxide and produces this oxide, sodium oxide, and remove this by hydrogen and this the alcohol. Fate of the free radicals. Addition reaction, dispersion reaction, vinyl polymerization, rearrangement. Dispersion of free radicals is termination step in the free radical reaction where two radicals react, and instead of combining, one radical is oxidized and other is reduced, giving two stable non-radical products. It is called dispersion because one radical is dehydrogenated, oxidized, and other is hydrogenated, reduced. In case of alkyl free radicals, one the free abstract hydrogen and forms other. Donor radical loses hydrogen, becomes the alkene, oxidized. Acceptor radical gains hydrogen, becomes the alkane, reduced. Mechanism, hydrogen abstraction. One radical pulls a hydrogen atom from the beta carbon or another radical, products forms an alkane, and alkene is terminus radicals. For example, ethyl radicals. This is the ethane and the ethene. Ethane from hydrogen gain, ethene, hydrogen loses. Another example. Okay, it's all about the chemical reaction of free radicals and fate of free radicals. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you again.